question 45 of civil engineering paper of GATE 2018 forenoon session. A conventional drained triaxial compression test was conducted on a normally consolidated clay sample under an effective confining pressure of 200 kPa. The deviator stress at failure was found to be 400 kPa. An identical specimen of this same clay sample is isotropically consolidated to a confining pressure of 200 kPa and subjected to standard undrained triaxial compression test. If the deviator stress at failure is 150 kPa, the pore pressure developed is. So this question has two parts. In the first part, a drained triaxial compression test was done on a normally consolidated clay sample. The confining pressure was 200 kPa and the deviator stress at failure was found to be 400 kPa. In the second part of this question, an undrained triaxial compression test was done for same or identical specimen of the same clay sample, and at that time the confining pressure was 200 kPa and the deviator stress at failure was found to be 150 kPa. So in the second part, that is under undrained triaxial compression test, the pore pressure developed is. So we need to find the pore pressure developed in the undrained triaxial compression test. This question is from the topic of triaxial compression test. If you wish to explore your knowledge about triaxial compression test, you may watch lecture 34 shear strength soil mechanics geotechnical engineering 1 by Professor Dilip Kumar Vaid, IIT Kharagpur. So from the drained triaxial compression test, we have a relationship between the stresses for the failure plane, and the equation is sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. This is for drained triaxial compression test, and it is also written that the clay sample is normally consolidated. So for C dash for a normally consolidated clay is 0, is negligible. So as it can be seen in this picture, if failure envelope is passing through the origin, so it means the value of C dash or cohesion is 0. So we can say the equation becomes sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2. This term will be 0 as C is 0. So now in the question, the confining pressure, that is sigma 3 is given. In the first part of this question, confining pressure is given as 200 kPa. So sigma 3 is 200 kPa and deviator stress is given as 400 kPa. 400 kPa. So sigma 1 is equal to sigma 3 plus deviator stress, that is confining pressure plus deviator stress, which is equal to 200 plus 400, that is 600 kPa. That is, this is sigma 1. So 600 is equal to sigma 3. The value of sigma 3 is 200 kPa tan square 45 plus 5 by 2. So from here we can say this 200 and 300 will be cancelled with 3. So we can say this tan square 45 plus 5 by 2 is equal to 3. So this is for drained triaxial compression test. Now in the second part of the question is the undrained triaxial compression test was done. So for undrained triaxial compression test, the relationship between the stresses at failure plane is sigma 1 dash is equal to sigma 3 dash tan square 45 plus 5 by 2 plus 2c dash tan 45 plus 5 by 2. Now again this is the identical specimen of the clay sample, that is normally consolidated clay sample. So we can say for C dash will be 0 again. Now sigma dash means this total stress sigma 1 minus pore water pressure is equal to sigma 3 dash again sigma 3 minus pore water pressure, and this is tan square 45 plus 5 by 2. Now in the second part of this question, the confining pressure is given as 200 kilopascal. Confining pressure, that is sigma 3 is 200 kilopascal, and deviator stress is given as 150 kilopascal. So sigma 1 will be sigma 3 plus del sigma, that is 200 plus 150, so it will be 350 kilopascal. Now putting this value in this equation, 350 minus pore water pressure is equal to sigma 3. So sigma 3 is 200 minus pore water pressure, and tan square 45 plus 5 by 2 will be 3. Why? Because this the clay sample is identical, so value of 5 will be same. So tan square 45 plus 5 by 2 is 3. So this will be 350 minus u equal to 600 minus 3u. So after solving it, we will get u is equal to 125 kilopascal, that is pore water pressure in undrained triaxial compression test is found to be 125 kilopascal. So we can say the pore water pressure developed is 125. 125 is the correct answer for this question. Thank you.